Hi folks, so we're going to pretty much wrap up this AU 11,000 today. The refurb process itself is pretty much done. The owner does want to do a few other things, which I'll discuss in a little while, but if you recall, one of the things that we needed to do was find a power switch for this because the power switch was broken and missing the back half, so it was just flopping in the breeze and somebody had bypassed it. So I want to talk about how I'm going to replace the power switch, or more correctly, how I went about finding the correct switch. Now, my first impulse was I have a AU719 here that's pretty much a parts unit at this time, and I was just going to take it out of that, but I looked through the manual and it didn't look like it was going to be beefy enough for this application. So I went to eBay and I started looking around. I did a search for Sansui power switch, and I found one that looks like it's going to be perfect. So let's take a look at what's going on here. Okay, so this is the power switch that I took out of the unit. You can see if you look here that there's nothing on the back. This is the replacement I got. You can see it looks virtually identical here, but it's got a few more pieces on the back here, which is the actual switch. This is just a levering mechanism. And it also has a snubber capacitor on here, because when you turn this unit off, or in fact when you turn pretty much any unit off, you're going to get an arc across the switch, and this will help quench that arc. That's the whole purpose of this, and it adds longevity to the switch. Now I'm going to show you some pictures of this thing, and I want to show some shots from the service manuals. If you look at the auction I found, it lists this as a switch for a Sansui AU7900. Now, you might think, well, this is probably a lower powered unit. I'm not sure if this is going to work or not. It does look like the right switch. And as it turns out, indeed it is, because if you look at this page from the service manual for the AU11000 we have on the bench here, you can see that the part number for that switch is 1170330. I'm going by memory here because I haven't edited this video yet, but that's the part number for the switch in our AU11000. Now, if you look at this sheet from the service manual for the AU7900, you'll see it's the identical part number. So it's not unusual for manufacturers to take a switch and use it in lesser powered models, because it'll work fine in that application. You just can't use it in a higher powered model. So we're going to put this switch in, and then we're going to replace the micas on the output transistors. I'm going to show you how to get one of the output modules out, and also just one of the transistors. I'll do the rest of them off camera, because if you've seen it once, you've seen it enough. You can always rewind it and look at it again. It's a fairly straightforward procedure. All right, so I got the switch soldered in off camera, but I want to point out something to you. Occasionally, you may come across a unit that is giving you weird symptoms, like the lights on the front flicker when you turn it on. This is especially true with receivers where you have a lighted dial. And you might hear crackling or something like that. A lot of times what that's caused by is the power switch contacts get burnt over time. That's what this capacitor is supposed to prevent. You'll see sometimes they'll use snubber networks that are made up of a resistor and a capacitor, but the switches over time and enough decades of service can still wind up with burned contacts. So what you can do in a case like this is they've only used one side of this switch, and all you have to do is take the wires and the cap off and put them on the other side of the switch, and it'll be good for another 20, 30, 40 years. So that's nice when they only use one side of the switch. You can just change it over to the other set of contacts and you're good to go. Alternatively, you can also jumper them over and you'll have twice the power rating. But I'm just going to leave it like this. If we have any problems with the switch in the future, we'll just go to the other side. Okay, so I've got the switch installed in the front here. And I'm going to leave it turned on because I haven't had a power switch to deal with on this thing in a while. And I can just see me turning this on, going, wow, why doesn't it work? And it brings up something I want to discuss briefly here, and that's the that's mistakes. You know, we are humans. We make mistakes. We try to minimize them, but know that you're occasionally going to make a mistake. Now, if you remember the trouble we were having in the tone controls back in part 5, that was caused by me. When I went and installed this transistor, these transistors together with the common emitter leg, they're splayed out like this, and as I pushed it through the board, it probably pushed and broke the trace on the printed circuit board. These are very, very delicate at this age. Printed circuit board is nothing more than a piece of, they've used fiberglass, phenolic, all different kinds of material, just non-conducting material with a thin sheet of copper glued to the bottom. And they etch away the copper they don't want, leaving the traces. But over time, the adhesive properties of whatever they use tend to go south, and the traces can come off the board, and they're very thin and they're easily broken. And I want to point this out to you because if I would have straightened the legs out instead of having them splayed like this, it may not have happened. So it's often said that a smart person learns from their mistakes, but let me add to that, that a wise person learns from the mistakes of others. So be wise. See the mistakes that I make and learn from them. Now, I haven't made every mistake there is to make, but I am working on it. The other thing is I have enough experience to find and fix my own mistakes. And this can be a problem when you're starting out. That's why it's always recommended you just do one board at a time and test. That way if you have a problem, it's a lot easier to isolate where that problem is. It was the last board you worked on. Unfortunately, due to the way that this is all put together, we did multiple boards at once, and wouldn't you know, that's when we had a problem. I've discussed Murphy and Murphy's Law. He's just got it out for us. I don't know why. But anyhow, I just wanted to discuss that. Learn from the mistakes of others. So what we're going to do is we're going to pull each one of these modules one at a time and take transistors off, clean them up, put new thermal compound and new micas in there, and then reinstall everything. All right, well, you can see all these connectors are already pulled because I finally got in the capacitors I needed to replace up here at the top of the board. Remember, there were 4 3.3 microfarad to 63 volt. I got tons of them at 50 volt, but I had to order ones for 63. So these are already pulled. And what we're going to do here is we have to pull the connectors for here. This is the power connector. Oh, this has to come out. And this has to come out. And now we can pull this one module out. So all we have to do is take out the 4 screws at the bottom. 4 screws, 2 at the bottom and 2 at the top. Sorry. Okay. Now, even though all we're doing is replacing micas, when we go to fire this up again, we're going to use the dim bulb because there's always a chance, even though I've taken pictures of this, that a mistake has been made, and it's so much easier to stay out of trouble than it is to get out of trouble. And I also have this brown wire here that has to be pulled. Okay. Has to come out of this connector. Okay. Okay. And now we have the module out. Now that I have this out, I want to point out that when you remove this little gizmo right here, you need to be very careful. This is a thermistor, and it is measuring the temperature of one of the output transistors. They use this information to keep the bias from thermal drift, and you do not want to break this. So be very careful when you take these things off, not to break them. These are fairly hardy, but the leads can break out of the bottom here. This looks like it may have been glued in, but in any event, use caution. All right, so I took the screws out of this one, and they were quite loose. There's a torque specification for these. I don't know what it is. I don't have a torque screwdriver. I would get one if I just would know what to torque them to. I make sure they're snug. The whole point of this heatsink assembly is to make sure you transfer the heat away from the transistors. Heat is the enemy of semiconductors, so it's very important that we have good thermal compound and that they're nice and snug against the heatsink. So when we pull this out, you can rock it out of here. You can see it had thermal grease on it, and it hasn't dried up too much. We were going to replace the micas, clean up the transistor, clean up the heatsink, and put new heatsink compound on. Now, I buy this stuff by the pound. I buy in bulk because I go through a lot of stuff, and it is way, way cheaper. At the time I bought this, it was $20 for a pound, or I could have paid $10 or $12 for a 2 or 3 ounce tube. This is good stuff. It's GC Electronic Z9. And I buy the micas from Mouser 100 at a time. The part number for these is 534-4662. These are known as TO3 transistors, which refers to the case. And let's just clean everything up. One nice thing about the grease they used is it doesn't make as much of a mess. This white stuff does, but it's really good quality and it gets the job done. So we just take the old stuff off, and then we take one of the micas, and a little of this stuff goes a long way, and you want to keep a rag handy because you can see just taking the top off, I've got this stuff everywhere. Word of the wise, wash your hands before you take a leak. You don't want to find this stuff some places. I've found it. Okay, so like I said, you don't need much, just a little bit. A thin layer is better than a thick layer. So I just put it on both sides of the mica. And as you can see, we get it everywhere. That's way too much, but we'll get the excess off. Okay. God. All right, I got my left hand fairly clean, so I'm going to grab the transistor. These appear to be the original outputs. That's a good thing. We can replace these, but the originals are best. Okay. All right, get this crap off my right hand. You have to be careful to make sure the pins actually go into the socket and just don't bend. You have to rock them around a little bit. It's a feel thing. Those are in, okay? And I always torque them down by hand. I don't mind using the electric screwdriver to take things out. I almost never use it to put things in unless I'm very confident that I can put them in without cross-threading. And I specifically want to feel how tight we're getting these. Doesn't have to be, oh my God, tight. You just want them snug. It's all about heat transfer. I really wish I had a good torque specification, but sadly I don't. If anyone has one, please post it on there and then we'll all know. Okay, so I just take the excess off the top. Okay. So I'm going to do the others off camera. There should be 4 to a module, 2 on this side, 2 hidden on the other, and then we'll put it back. By the way, while we got this out here, these are our emitter resistors. This is where we're going to measure the bias. And I want to show you something here. Let me go back to autofocus. Okay, apparently I can't do this with the camera on. I need to move things anyway. This is an Lcr meter I bought, and I want you to pay attention to the leads. These are known as Kelvin leads or Kelvin clips. And the beauty of this is if you have a meter that has 4 inputs on it, you can nullify the lead resistance by the use of Kelvin leads. They can be very expensive, but I found some good deals on Amazon and Alibaba. They're made in China, but they're very reasonable and they seem to do a good job. In fact, I got this Lcr meter through Alibaba. The shipping was quite reasonable. It came in a good, short amount of time. Very pleased with the purchase. But when you're measuring very small resistances, like these emitter resistors here, that's where these things shine. Now, we rarely need to know what the exact resistance of an emitter resistor is, but just to give you an idea, and remember these are in circuit, these are 0.33 ohm, and if you look at our meter, it says 0.3255. And if we look at the other side of that, that should be double. This is where we're going to measure our bias. We'll do the math, we'll see what we're supposed to get, but we should get around 20 milliamps of bias, and we're going to measure it right across here. We'll take a look and see what the manual has to say, but I am always happiest when I actually know what is going through here. Okay, so I'm going to do the rest of these off camera. We're going to put everything back together here. I'm going to check the bias. I'm going to check the offset. And this thing will be pretty much done except for the modifications the owner wants. And I did want to discuss those, and this is as good a time as any. The first thing he wanted to do is he wanted better speaker connectors. Let me move the camera here. Let's try not to get seasick. If you look here, these are the stock connectors, and he wants these changed out. And what I'm going to try to do, and let's see if I can do this. Where's my 4th hand when I really need it? Okay, so let's just put this down here and move the camera. That's not bad. So what I want to do, I don't want to cut any metal out of here. I can take this piece out with these screws. And what I want to try to do is I'm going to have to offset these, but I believe I can get these bananas in here without cutting any metal away. My goal is to make any modification I do reversible. Now, this gentleman may own this the rest of his life. It may never come on the market, or he may get tired of it, want to sell it and get something else. Always nice to be able to give the old connectors and go, hey, if you want to go back to this for whatever reason, here they are. Now, the other thing he wants to do is not going to be reversible, and I hate to do it because it's going to necessitate cutting the back of the unit. He wants the power cord replaced with an IEC. So what I'm going to have to do is cut through the chassis, so cut through the back, so I can mount this. And I'm really loath to do so, but it's what the gentleman wants, and what he wants is what he will get. Anyhow, let me get the rest of this stuff all off, get these transistors all greased up, and then we'll get ready to put this back together. Okay, a couple things I want to mention before I put this back in. This is the last heatsink assembly we have to put back in. And if you remember, I pointed out this thermistor here. When you go to screw it in, secure it with your finger like this, because as the screw starts to grab and tighten down, it's going to twist this. You don't want to put any stress in these wires. So stick your finger here as you tighten it down. All right, just wanted to point that out. And then the other thing I want to talk about is this style of transistor. This case is known as T03, and that is the case style. Now I grabbed an old transistor here, and if you hold them like this, these leads are closer to the bottom of the case than the top, and that will make this the emitter and this the base. And it also matters when you're putting these micas on, because if you put them on upside down, the holes aren't going to line up. Okay, so if we hold it like this, we know this is our emitter, this is our base, and if we line up the mica the same way, now the mounting holes line up. So it's very important that you put them on the right way, or it's just not going to work. Okay, so I'm going to put this back in. I'm going to put the board, the driver board back in, and we're going to crank it up on the dim bulb because we've moved connectors, and while I'm confident, I took pictures, I'm putting them back in the right place, we're going to start it up on the dim bulb anyway, just to be safe. Okay, so we've got this thing all put together here, and they want you to do the bias a lot like we do the bias on the Sansui 9090, in that we're not measuring directly across the emitter resistors. Instead, they want us to measure how much current is being put out of the output stage into each one of these transistor blocks. So what you do is they want you to pull the red lead off the power supply board here and insert your meter in milliamp mode. So I've done that, and since, as I've said in the past, I have an embarrassment of meters, it's easy to hook up 2 meters so I can do both channels simultaneously. Now let me just move the camera a little bit so you can see the very top here. Okay, bias current, this is what we're looking at. They want 50 milliamps, give or take 1 milliamp. They also want you to run the unit for more than 5 minutes after the power is switched on, and we have done that. Now remember, I moved the trimmer pots to the back of the board. That means they are going to essentially be backwards. So in order to turn the bias up, which is the direction we need to go, I need to turn counterclockwise, opposite of what it was when they were mounted on the other side, but boy are they easier to get to now. So I'm doing the left channel, and it's 50 give or take 1. Right channel, and it's pretty touchy. Let me move this, get the glare off of it. Okay. Okay, I'm liking these. Now, it's been on quite a while now, but I'm going to leave it on a little while longer and see if it settles or changes. Sometimes you don't want these things to run away. So it's important you set the bias either right where it's supposed to be or a little bit low. You don't want to set it high. But it says give or take 1 milliamp. So this looks good. This pretty much concludes the rebuild of this, except for the modifications I have to make. This is going to be the last installment of this upgrade process. I will post another video after I've got the plug cut in the back and the speaker terminal is modified. But for all intents and purposes, we are good now. So I'm going to sign this video off, and there's something nagging me, something I wanted to discuss, and now I can't remember what it was. Oh well, that'll be in the next video. Anyhow, I hope you've enjoyed watching this, hope you learned something, and as always, I like giving back to the community that has given me so much. Thanks a lot, folks.